So there were so many questions about this particular assignment. Um, so I'm going to go through, so I am going to post, you should probably have already seen it, I guess, all of the solutions. I've worked through every problem. But I'm going to go through the three most frequently asked about questions really quick in person. And so the numbers I'm going to do are number, let's see, 3, 5, and 7 and 8 were both asked about, but 8 was definitely the more complex one, so I'll do 8. Okay. Yeah, 8's going to be long, so here we go. Hopefully we can get through it pretty efficiently. Okay, so we're going to start with number 3. Okay, so for number 3, it gave us that y was equal to e to the x was a function that we were looking at. I think it gave you a picture too. So we have like our function. This is not at all. This should be like straight, whatever. And then it gave us a normal line that intersected e to the x at a point and also contained the point 6, 3. Okay. And the goal of this was to, let's see, I believe, figure out the slope of this normal line. Okay. So normally, if I knew this point right here, I would find the slope of the normal line by taking my derivative, which is just e to the x, subbing in the value, and then flipping it and negating it to get the normal slope. So our m sub t is going to be just e to the whatever x value is at this point. So let's call this something so that I can sub in a value, if that makes sense. Okay, so we're going to call this PQ. You could have used AB or RS or anything you wanted to. So my MT is going to be, so at x equals P is going to be e to the P. This means my MN is -1 over e to the P. Okay, so that's technically my normal slope, but I really need to actually find the number. That's what the problem is asking us to do. So basically, I'm going to go back to the elementary idea of slope, and I'm going to rewrite this slope in another way. Okay, so I have this way to write slope. I'm also going to write out, so for a line, right, slope is constant. So for this e to the x, slope is not constant. So we have to have a particular point to sub in to actually get this normal slope. But for a line, slope is just going to be, it can just be the average slope between 2 points, okay? So, and this is the normal slope for this point right here, but the normal slope is also going to be equal to the slope at any point along this line because this is the normal line. So I also could have that MN is equal to, so it's basically rise over run. So I'm going to have 3 minus Q over 6 minus P. Now I can get a little more specific here. Right now I have 2 equations and there's this extra variable Q in it. I want that Q to be in terms of P so that when I set the 2 slopes equal to each other, I have the same variable in there. Now this Q is really just the same thing as P comma, the function right here is e to the x, so I can sub in P to my function to get my y value, so e to the P. So this is really just 3 minus e to the P over 6 minus P. Okay, so now I have 2 equations for slope. This one right here and this one right here, normal slope specifically. So I want to set them equal to each other. So I'm going to have that -1 over e to the P is equal to, I think I did this the opposite in the notes that I posted for you guys, but it doesn't matter. This is just a factor of 1 on top and on bottom, and so it really doesn't matter, they cancel out. So I have these two things equal to each other. This is a calculator active problem, so don't try to solve this. That would be really obnoxious because you have both an exponential and then this like little linear piece. So let's type in -1 over, e to the x. Okay, and then on my other one, I'm going to have 3 minus e to the x over 6 minus x. And I'm going to graph those two functions. Okay, so I'm going to get the first one there, second one here, and they're very close together. So I'm going to zoom in my window. Just so I can see more clearly. So there's my -1 over e to the x, and here's my rational function. And then this is their intersection point right here. Okay, so you're going to do second trace, go down to intersect, first curve, second curve, guess, and it should guess right here. It tells me that my p-value, so using my GDC, my p-value is 1.415. Okay, now I can sub this p-value back into either one of these sides, so either this or this to get my mn. But really, it's going to be the same, right? Because this p-value is when both of these are the same. So this y value right here should give me my slope. So my slope, my normal slope, is going to be about -0.243, and that is what is on my screen right here. So this is what they were looking for. That would be the final answer. Okay, so really all it is finding slope in two different ways, and then setting those two ways equal to each other when they have the same variable on the inside, and then solving that system of equations. Okay, so that was number 3. I'm going to go to number 5. Okay, so in number 5, this is the same sort of concept, okay? So in number 5, it gives us two functions this time. Okay, so this is the same sort of concept, but this time, we have, I'm going to draw out the picture here. We have the function cosine, and we also have our natural log function, our logarithmic function, and it's saying that they have, this is not horizontal, so the same slope, at some point on the function. Okay, and we want to figure out what. So in this case, there are 3 curves that have the same slope at a particular point. At this point, this curve will have the same slope as this curve at that point, and both of them will have the same slope as this line the entire way through. Okay, so the line has the same slope the entire way through, which is equal to the cosine slope at this point and the logarithmic function's slope at this point. Okay, so let's name these points. I'm going to name this one A, and my y value for it, I'm going to go ahead and do this so that I don't waste time like I kind of did in the last one. My y value should be the cosine of A because that's the value on that curve, okay? This one is going to be B, comma, the natural log of B because that is the y value of the point B on that curve. We just sub in B, we sub in A to get those points, okay? All right, so let's go ahead and figure out what our tangent slopes are going to be. So my MT is equal to y prime, which is just 1 over x. And if we do it at our point, because the slope changes along this curve, but at my point, I want to sub in B. So my MT, I meant to write what point I was looking at. So at x equals b, mt should be 1 over b. Same thing for the other function. So mt should be y prime, which is negative sine of x. And when we go to this specific point to calculate the slope, we're going to need to go to x equals a. So my mt in that case will be negative sine of a. Okay, so now I have two of the three slopes, two of the three ways to write slope. Okay, now I need to figure out my third way. So this is convenient that we have three ways to write it because we have one variable here, another variable here, and we this would create basically one equation. We need a third equation to be able to solve for that other one. So again, this is a line. It has the same slope the whole way through. So I can use my, so for my line, I can use the most elementary idea of slope and just do difference of change in rise over change in run, and have my MT be, so I'm going to do, and you could do this either way, ln of b, as long as it's in the same order and the top and the bottom, minus the cosine of a over b minus a. It's totally fine if you have the cosine of a minus the natural log of b over a minus b. That's the same thing, okay? So now I have three different ways that I have written my slope, okay? All three of these ways are equal. They should give me the same value. So what I'm going to do is I'm going to set these two equal to each other. So I'm going to have that 1 over b is equal to negative sine of a. Now I have one variable in terms of the other variable, which I could sub into this to be able to solve. So I'm going to solve for b because b is the easiest one to get by itself. When I do this, I should get b equals negative 1 over the sine of a. If you didn't follow that because I didn't do the algebra, try it. And if you get confused, just send me a message and I'll try to explain it. Okay. So now we have b in terms of a, and I can sub this into here so that I only have one variable in this. So this is going to be equal to, so we're sub, why can't I spell? Sub in b. So I'm going to have the natural log of negative 1 over the sine of a minus cosine of a all over negative 1 over the sine of a minus a. Okay, so that is our third equation. Now we want to use this equation and one other equation to find the intersection. Now we choose this equation to look at specifically because it's in terms of a. We want to pick equations that have the same variables, okay? So when I'm going to sub this equation. So sub these equations into your graphic display calculator and solve for intersection. Okay, so the equations I'm talking about are this equation for the tangent slope and this equation for the tangent slope. Okay, so there's our two equations. So when I do this, okay, so just trust that I have done this multiple times already. So between helping you guys and all